Okay, students. So after discussing the synopsis of modulus function and greatest integer function, now we shall discuss problem on that. For the problem number 11, I have taken limit extending to 3 minus mod of x minus 3 divided by x minus 3, where option A is 1, option B is minus 1, option C is 0 and option D does not exist. So for this problem, we shall go for substitution method. I will discuss in detail substitution method after this particular problem. For this, let us take put x equal to 3 minus h. Clear? So now, limit h tending to 0 mod of 3 minus h minus 3 divided by 3 minus h minus 3. Very simple, as you all know, plus 3 minus 3 will get cancelled, plus 3 minus 3 will get cancelled. Limit h tending to 0 mod of minus h divided by h. This will be your solution of this particular thing. What is mod of minus h? It will be h divided by minus h. Cancel these two terms. So answer will be minus 1. So your option B is correct. For limit extending to 3 minus mod of x minus 3 divided by x minus 3. Okay. In this particular problem, let us discuss your substitution method in detail. Clear? So what you are substituting here? X equal to 3 minus h. Okay. Most of the students will get confused with h tending to 0. Sir, here it was x tending to 3 minus, then why here h tending to 0? Most of the students will get confused. Clear? So for that reasons here, x equal to what you are substituting? 3 minus h. If you simplify this, h will be equal to what? 3 minus x. Now what is your h equal to? 3 minus x. So now here you observe that x is going to what? 3, as x goes to 3 here, where h goes 0. Have you understood this? As x goes to 3, h goes to what? H goes to 0. Are you clear? So from this problem we can see that if I put x equal to 3 minus h, again why only 3 minus h? Because x is going for 3 from left hand side. Please remember it. X is going to 3 from left hand side. So that's why we take it as 3 minus h. Please remember 3 points. That is, we are putting x equal to 3 minus h because x is going from left hand side of 3. This is first thing. Second thing, if x equal to 3 minus h, h will be equal to what? 3 minus x. Are you clear? So then, if h equal to 3 minus x, this is your second point. That is, x equal to 3 minus h means h equal to what? 3 minus x. Then what is your third point? That is, as x goes to 3, h goes to what? 0. Have you got my point? That is, in substitution, the thing you have substituted that 3 minus h. So as x goes to 3, h is going to 0. So we replace h tending to 0. Have you cleared this? So that is 3 plus 3 minus 3 will get cancelled. For further simplification, you know, that is limit will be equal to minus 1. Okay. Now let us go for next problem. Okay students. Now see 12th problem. Just only a small change from 11th problem to 12th problem. That is limit extending to 3 plus. In the previous problem we discussed the left hand side of 3 for the same function. Now here we are discussing right hand side of 3 for the same function with substitution method. As you all know, what you have to put here? Put x equal to what? 3 plus h, because here x is going to 3 from right hand side. Are you clear? It is going from right hand side. So put x equal to 3 plus h. Directly I will write as x goes to 3. again h goes to what? 0. As x goes to 3, h goes to 0. So it will be what? Limit h tending to 0 mod of 3 plus h minus 3 divided by 3 plus h minus 3. Cancel minus 3 and plus 3. Cancel minus 3 and plus 3. So here again it will be limit h tending to 0 mod of h by h you are going to get cancelled. So answer will be equal to 1. So see here, your left hand limit was minus 1 and your right hand limit will be what? Plus 1. So your answer will be plus 1 from right hand side. From left hand side it was equal to minus 1. Clear, students? So then we shall discuss one of the property of this particular function. This is in the form of f of x equal to mod x divided by x. It is in the form of mod x divided by x. Already you will be discussed the Signum function in your functions and relations chapter. Sorry, that is relations and functions chapter. In that particular chapter we will be discussing this as Signum function. So as you all know, Signum function has three values. One is minus 1, second one is 0, and third one is plus 1. That is, whenever x is greater than 0, whenever x is equal to 0, whenever x is lesser than 0, whenever x is equal to 0, and whenever x is greater than 0. And the graph of Signum function will be like this. Clear? So if you know this property for this particular problem, you can directly choose the answer. How you can choose the answer? You all know for every x which is positive, it will be 1. For every x which is negative, it will be minus 1. At 0, it will be equal to 0. So see here, x tending to 3 plus, that means positive side of 3. I am talking about positive side of 3. Right hand side of 3. Clear? If I go for right hand side of 3, if you know this function and the properties of this function, directly you can tell the answer is 1. There is no need of solving this. So this particular thing is going to play as a very shortcut for you in this particular problem. Please understand, that is, whenever it is of right hand side of 3, that means positive side of 3, we go for plus 1. Why? Because we know these properties. Clear? Again, the function is having jump from 0 to plus 1 and 0 to minus 1. There is no continuity here of this particular graph. Are you clear? So left hand side will be equal to how much? Minus 1, as we all discussed in problem number 11, because it was left hand side of 3. Are you clear? So left hand side of 3 you can tell, or the negative side of 3 also you can tell. Have you got my point? So if I go for negative side of 3, it will be minus 1. If I go for positive side of 3, it will be equal to plus 1. By using the nature of Signum function, directly you can tell the answers of this particular problem and problem number 11. Have you understood my point? Okay. Now let us go for 13th problem. Here I will remove plus. Now you have to discuss limit extending to 3 mod of x minus 3 divided by x minus 3. That means you have to discuss the limit of 3 for this particular function f of x. Problem number 11 says that this particular problem from left hand side it gives minus 1. This particular problem tells that from the RHS of extending to 3 it gives plus 1. So if I take problem number 11 and problem number 2, your LHL equal to minus 1, RHL equal to plus 1, therefore LHL is not equal to RHL, hence limit does not exist for your problem number 13. To solve problem number 13, you go for problem number 11 and problem number 12. Problem number 11 gives LHL, problem number 12 gives RHL. So LHL will be not equal to RHL. Therefore, for this, the answer will be does not exist. If you need a shortcut for this particular problem, you should go through this, the nature of Signum function. It will be having the jumps from +1 to 0, again 0 to -1. So there will be a break here. So therefore, we can tell that limit does not exist for this particular problem number 13. Okay students, now let us go for problem number 14. So problem number 14 tells that limit extending to 2 plus, that means the right hand side of 2 for the given function, that is greatest integer function. Here this is greatest integer function. It is given as greatest integer function. As you all know the nature of greatest integer function, this will be very simple problem for you. See here, that is they are giving limit extending to 2 plus greatest integer of x. Again go for substitution method. Limit extending to 0, it will be 2 plus h. Now I will not write each and everything. You have to understand. As greatest integer function tells 2 plus h, that means negative infinity, positive infinity. This is 2. 2 plus h will be here. This is 3. Clear? So 2 plus h will be in between 2 and 3. 2 plus h will be in between 2 and 3. So as you all know the nature of the greatest integer function, for 2 plus h it will be equal to, for 2 plus h it will be equal to 2, because it is in between 2 and 3. If you don't understand, see my previous video. At last I have discussed what is greatest integer function and the definition of greatest integer function, the examples of greatest integer function. So you have an idea of how it is going to be equal to 2, because it is in between 2 and 3. So it will be 2. Clear? Next, what is your answer here? So it is 2. Clear? Okay. Now let us go for 15th problem with 2 minus. Have you understand? Let us go for 2 minus. What is solution for this 2 minus? So limit extending to 2 minus greatest integer of x, that is equal to limit extending to 0, it will be 2 minus h. Clear? So see here, positive infinity, negative infinity, 2, 3, 1. 2 minus h will be in between 1 and 2. This is 2 minus h. So 2 minus h will be in between 1 and 2. From the nature of greatest integer function, it goes to what? 1. So answer will be equal to 1. You got my point? So answer is 1 for your 15th problem for the greatest integer of x as x tending to 2 minus. Have you got my point? See here, RHL was 2, LHL is 1. Have you got my point? So RHL is 2, LHL is 1. So LHL is 1. If I take 16th problem and if I remove this, what is my 16th problem? Limit extending to 2. See here, limit extending to 2. What is this particular function? Is it 1, minus 1, 0 or 2? And option E I will take it as does not exist. DE means does not exist. So you can tell that the answer is does not exist. Clear? So answer here it is does not exist. Why? Because LHL is 1, RHL is 2, therefore LHL is not equal to RHL. So your answer will be does not exist for problem number 16. Problem number 15 for right hand side of 2. Problem number 14 right hand side of 2. Problem number 15 left hand side of 2. Problem number 16 as extending to 2. Clear? So if you calculate as extending to 2, see LHL is not equal to RHL. LHL is 1, RHL is 2, therefore LHL is not equal to RHL, hence limit does not exist. Okay students, if this type of problem comes in your exam, please remember greatest integer function at non-integers, it is continue or limit exist for non-integer, but for integers, greatest integer function is always does not exist. Please remember this, limit does not exist for the greatest integer function. As you discussed for the Signum function also, limit does not exist for the integers. On the same way, the greatest integer function will also say that the limit does not exist for your integer points on your real number line. Okay students, now we have done with 16 problems. In these 16 problems, the important things I will discuss. First point, Signum function, limit does not exist, limit does not exist. Next, greatest integer function, limit does not exist at every x belongs to integer set, at every x belongs to integer set. Then for Signum function, limit does not exist, therefore here for greatest integer function, limit does not exist for every x belongs to integers. For the Signum function, you check at what point they have given. So in that point RHL will be +1, LHL will be -1, therefore LHL is not going to be RHL for here, therefore limit does not exist. Here also LHL is not equal to RHL, limit does not exist. Here LHL will be equal to -1, RHL will be equal to +1, therefore -1 will be not equal to +1 in the Signum function, hence it is not going to be exist at any extending to A, at any extending to A where A belongs to real numbers, where A belongs to real numbers. Please remember these two notes, very very important for your JEE exams or as well as any competitive exams. Why? Because if you see these two or if you remember these two from problem number 11 to problem number 16, directly you can tell the answers, what the answer is going to be. Be perfect with the greatest integer definition, be perfect with the modulus function definition, and have the properties of modulus function nature as well as greatest integer function nature, so you can directly go for the answers without solving it. Okay, take the note of this. My dear students, let us go for 17th problem. See the 17th problem. Limit extending to k minus x minus greatest integer x. That means fractional function. The given function is fractional function. This all comes under important special functions in your first year syllabus or 11th class. Clear? Or some students say it as +1. Clear? So in +1 class or the 11th class, you will be studying this special type of functions: greatest integer, modulus, fractional, exponential, logarithmic. Those all comes under your special functions. So x minus greatest integer of x is fractional function. Already you know this, that is greatest integer function, how to simplify. this no problem because it is algebraic. Algebraic plus or minus greatest integer will be your fractional function. So for that reason, let us try to solve this. Before I solve it, try yourself. I will be solving no problem, but try yourself by pausing this video. Most of the students get answer as does not exist. Why? Because I already explained greatest integer function will be does not exist. They will be having it in their mind and they directly say that it is does not exist. But let us see what the answer will be by solving this. Limit. I will go for substitution method. H tending to 0, k minus, that is k minus h minus greatest integer of k minus h of the greatest integer. K minus h of the greatest integer will be what? Limit h tending to 0, k minus h. This will be k minus 1. K minus h will be what? K minus 1. Again same. If you take this is k minus h will be on left hand side of k. This will be k minus 1, this will be k plus 1. So if you come left hand side of k, the greatest integer will be what? K minus 1. Okay, let us take h term as 0. If I take h term as 0, k minus of k minus 1 plus k minus k will get cancelled and answer will be plus 1. Minus into minus will be plus 1 and your answer is plus 1. Now I think why does not exist is your answer. Why does not exist is your answer? Because k minus, you are calculating the left hand side of k minus. If you calculate left hand side of k minus, it will be plus 1. Have you got my point? Because you are calculating at k minus. Clear? Okay. Let us move for 18th problem. In this 18th problem, I will take it as k plus this as minus 1, this as 0, and option D is does not exist. Problem number 18. So you try yourself. Problem number 18. What is problem number 18? Extending to k plus x minus greatest integer of x. Again, problem number 19. Limit extending to k x minus greatest integer of x. Same options. Try problem number 18 and problem number 19. In problem number 18, you are checking right hand side of k. That means k plus h. It will be what? K. Here you are going to get this as k. K will get cancelled. Clear? So check what will be your answer. Next, for the 19th problem, I am calculating at extending to k. Then if I calculate at extending to k, what will be your answer? Obviously it will be what? LHL is not equal to RHL, therefore it is limit does not exist for problem number 19. So my dear students, here you have to note one point. For fractional function at any real number, the function is with limit does not exist. Please remember, for the fractional functions also, limit does not exist. Make this as note. For x minus greatest integer x, limit does not exist at limit does not exist. Clear? At x equal to a, where a belongs to integers. Where a belongs to integers. For other than integers, you try yourself what it will be. Clear? Okay. So limit extending to k plus x minus greatest integer x. Check yourself. 19. Check yourself. These are the same options for 19 also. make this as note. If x is an integer, then what is that? Fractional function will be with no limit exist. Clear? Okay. Now I will move for problem number 20. Okay students, see problem number 20. It is given as limit extending to 0, greatest integer of cos x. What they are asking? Greatest integer of cos x. Here option D is does not exist. But please remember, before answering does not exist, see your greatest integer function. This is trigonometric function. I've got my point. Previously we discussed where the f of x was from domain to codomain with not trigonometric functions. Previously we discussed where the f of x was not a trigonometric function. In a not trigonometric function, it will be does not exist, no problem. But let us look for trigonometric functions. Limit h tending to 0, greatest integer cos of 0 minus h. I am checking LHL. 0 minus h. What it will be? Or we shall write it clearly. That is for LHL. Limit extending to 0 minus cos of 0 minus h. Greatest integer of 0 minus h. Okay. So this is the graph of cos x. Clear? If I go for 0 minus h, so this will be my 0 minus h, left hand side of 0. If I go for left hand side of 0, then what is cos of 0 minus h? See here. 0 minus h, it is in between. At 0, this is equal to 1. At minus pi by 2, this is again equal to 0. That means it is in between. That is in between 0 and 1. Clear? Cos of 0 minus h will be in between 0 and 1. Have you got my point? At 0, cos x is 1. At pi by 2, it is 0. At minus pi by 2, it is again 0. If I go for 0 minus h, it will be in between 0 and 1. That means the output of cos x will be in between 0 and 1. If the output of cos x will be in between 0 and 1, because of this greatest integer, it is going to be what? It is going to be 0 because of greatest integer function. So it will be, the output of this will be 0. Output of this will be what? Again 0. Have you got my point? Clear? For LHL, limit extending to 0 minus cos of 0 minus h is again 0. Clear? Okay. Next, let us discuss RHL. Limit extending to 0 plus greatest integer of cos x. Limit h tending to 0 cos of 0 plus h. So now it is going right hand side of 0. If I go for 0 plus h, it will be 0 plus h. Then that is right hand side of 0. Again from 0 to pi by 2, the cos will again remain in between 0 and 1. for 0 plus h also it is in between 0 and 1. Why? Because cos 0 it was 1, cos pi by 2 will be 0. Clear? Cos 0 it is 1, cos pi by 2 it will be 0. So in between 0 and 1, again in between 0 and 1, your answer will be what? Equal to 0 because of greatest integer function. Here this is your greatest integer and it is trigonometric. I got my point. So x will be 0 plus h. If I see the cos, if I go for 0 plus h, the range will be in between 0 and 1. The range of cos x will be in between 0 and 1 if I go for 0 plus h. So please remember that for 0 plus h, the greatest integer of cos will be again equal to 0. Therefore, LHL equal to RHL is equal to 0. That means limit exists for the greatest integer of cos x. Limit exists for the greatest integer of cos x. I think you got my point. Okay students, now let us go for LHL of 21th problem, that is limit extending to 0 greatest integer of sin x. Already we discussed cos x, now let us go for sin x. Limit extending to 0 minus sin x. This will be equal to what? Limit extending to 0 sin of 0 minus h. So now see the graph of sin x. This will be the graph of sin x. Here 0, pi by 2, and this is 3 pi by 2. Sorry, pi, not 3 pi by 2, this is pi. And this is 3 pi by 2, this is 2 pi. Clear? So this is the graph of sin x. Let us see for 0 minus h. For 0 minus h, that means okay, for 0 minus h, it will be here. That means in between 0 and minus pi by 2. Clear? In between 0 and minus pi by 2, the range of sin x will be 0 and minus 1. Are you getting my point? So this is 0, this is minus 1. It will be in between 0 and minus 1. Are you clear? If I go for 0 minus h, it will be in between 0 minus h, it will be in between minus pi by 2 and 0. So that is minus 1 and 0. It is in between minus 1 and 0, means your output will be minus 1. Your output will be minus 1 for the greatest integer of sin x. So here it is minus 1 for the greatest integer of 0 minus h. So now let us go for RHL, that is limit h tending to 0 sin of 0 plus h. Clear? If I go for 0 plus h, it will be here. This is 0 plus h. in the form of 0 plus h, it will be in between 0 and 1. It will be in between 0 and 1. If I go for 0 minus h, it will be left hand side of 0. So minus pi by 2, 0, that is minus 1 and 0. Your output was minus 1. Let us go for sine of 0 minus h. So for sine of 0 minus h, it will be in between 0 and 1. In between 0 and 1, your answer is 0. Your answer is 0 for the greatest integer of sine of 0 plus h. So that is for LHL it is minus 1, for RHL it is 0. Clear? Therefore limit extending to 0 of sine x does not exist. Okay. So now for problem number 22, limit extending to pi by 2, greatest integer of sine x we shall discuss. Okay students, now let us move for limit extending to pi by 2, greatest integer of sine x. Greatest integer of sine x. First let us check LHL, that is limit extending to pi by 2 minus greatest integer of sine x. Limit extending to 0 sine of pi by 2 minus h. Your greatest integer function is sine of pi by 2 minus h. According to your function, this is pi by 2, that is 1. At 0, it is 0. At 3 pi by 2, it is again 0. Clear? Okay. Pi by 2 minus h. Pi by 2 minus h will be here. This is pi by 2 minus h. So at pi by 2 minus h, the range of sine x will be in between 0 and 1. It will be in between 0 and 1 for pi by 2 minus h. So in between 0 and minus 1, what is your greatest integer? It is 0. Have you got my point? For pi by 2 minus h, it will be for the left hand side of pi by 2. So your range will be in between 0 to 1. See, this is 0 to 1. In between 0 to pi by 2. Answer will be 0. Answer will be 0. Now let us go for limit extending to 0 sine of pi by 2 plus h. This is RHL. For pi by 2 plus h, it will be here. That means right hand side of pi by 2. Again from 1 to 0. Again your range will be from 0 to 1. That means here it will be your range. So outputs will be from in between 0 to 1 from right hand side of pi by 2. Are you getting my point? See, from 0 to it goes to 1, it goes to 1 to 0. 0 to 1, come back from 1 to 0. That means for pi by 2 minus h, it goes to 0 to 1. For pi by 2 plus h, it comes from 1 to 0. That means your range is in between 0 to 1 for pi by 2 minus h as well as pi by 2 plus h. Therefore, for the greatest integer of in between 0 to 1, your output is again 0. Here again it is 0. Clear? LHL is 0, RHL is also 0. See, LHL is also 0, RHL is also 0. Your answer is 0. Have you got my point? So, very important point is be careful whenever greatest integer with trigonometric function is given. Whenever greatest integer function with trigonometric is given, you must know the graph of cos x and sin x, and you must know the nature of greatest integer function so that you can answer. I think you got what I have explained.